Earlier on, we looked at a persistent XSS attack. So that was one where we actually had cross-site scripting stored in the database, and then everyone who saw that record got hit with the XSS attack. Now I want to try and recreate that attack, and in doing so we're going to see another defense that's implemented on the client, which we're then going to circumvent. So here's what I want to do. I'm on the registration page. I'm going to enter an email address of jameshunt@f1.com. I'm going to give a first name of James, but this time for the last name, I'm going to paste in an XSS attack. And this is precisely the persistent XSS attack we saw just a little bit earlier. So that's going to be the last name. Now let me go on and set a password and confirm the password and try and register. And it hasn't really worked. We can see that we have an invalid last name. So there's something about this input that it doesn't like. And clearly it is malicious input, so it may well be that the application is just smart enough to recognize that and block the registration altogether. But one of the things I'm a little bit curious about is, was it the server that rejected this registration, or was it the client? So did the browser actually decline to even submit this to the server in the first place? Here's how we can find out. Let's hit F12 to open up the developer tools. I'm going to go over to the network tab. I'm going to then scroll back down to our register button, and let's now hit that again. Now there's been no network request, so this hasn't gone to the server. It looks like it's been rejected on the client. We can see why if we right click on this field and go down to inspect element. And in fact what we'll see here is that there's a data validation regular expression. And that regular expression only allows lowercase and uppercase alphabetical characters. Now that's what's blocking this script tag. It would also block anyone with a last name like O'Reilly as well, so this form actually has other problems. But what we're really interested in is the security side of things. So here's what I want to do to try and circumvent this control. I'm going to close the developer tools, and I'm going to go and bring Fiddler across again. So now Fiddler is running and capturing requests. Let's do this. I'm going to jump back over to the browser, and I'm going to change that last name to Hunt. So this should now pass the validation. Let's now go down and register. I'm going to flick back over to Fiddler. We can see some requests appearing, and now I'm going to stop capturing so that no other requests from my host appear here in Fiddler. Now the reason I've done this is to capture this first request, so the post request to register. And now that I have that, what I want to do is go and grab that request and drag it into the composer. The reason why I wanted to do that is because now I can modify that request body and add my malicious script and then see if we can register by posting direct to the server, thus circumventing the client-side controls. So here's what I'm going to do. I can't register twice with the same email address. So I'm going to go down and change it to jameshunt2@f1.com. The %40 is just encoding for the @ symbol. I'm then going to go and grab that last name, and I'm going to replace Hunt with my XSS payload. So this is the persistent one that we want to get into the database. Let's now go and execute this and we'll see what happens. So it appears to have run because we've got the same response again. We've got the 302, which then redirects to the home page at the root of the site and returns an HTTP 200. So we should now be registered with jameshunt2@f1.com. Let's now jump back to the website, and I'm going to log out the first James. So this is the James that we registered with the last name Hunt. So let's log that guy out, and then we'll go and log on with the new James. So this will be the James Hunt 2. Here's the email, here's the password, and now log on. So there we go. I've logged on with the account that has the XSS payload in the last name. The trick now is that I want to get that XSS payload displayed to other people. And the way I'm going to do that is I'm going to go and view the GTR, and I'm going to vote on it. And I'm going to now say, gotcha. Now, so far, that may seem pretty benign, but let me show you the significance. I'm going to go and log out James. And now I'm going to log myself back in. So this is my legitimate account. So I've successfully logged in. Now I'm going to go and look at the GTR. Let's see what happens. And suddenly I'm redirected. Here's that same evilcyberhacker.com website, and my cookies have been sent off. Now the reason why this happened is because when someone votes on a vehicle, their first name and their last name is recorded next to the comment. So what actually happened, and you might have seen it flash by very quickly, is that the GTR did load, and James Hunt's comment also loaded. But when his comment was shown, his first name and his last name with the XSS attack appeared in the source of the page. That's grabbed our cookies and it's redirected us here. So here's the point of what we've just seen. Client-side validation is great. It's very responsive, it saves callbacks to the server, it's a nice user experience. But the client can be easily circumvented. So you've got to complement every single client control with an equivalent server control. As an ethical hacker, when you're looking for vulnerabilities in a system, you want to look at every single control on the client that looks like it's designed to keep malicious content out of the system, and see if that control also exists on the server. So you just manufacture the request, just like we just saw. It could be in Fiddler or it could be in any other tool that allows you to construct an HTTP request and send it direct to the server. The other thing about this attack is HTTPS would not have stopped it. Transport layer security would simply load the XSS attack securely from the website. The victim would still have their cookies stolen, and there'd be no additional security simply by virtue of securing the transport layer. But of course, securing the transport layer is actually really important. Let's move on and start looking at insufficient transport layer security.